Hello.
And how are you, world traveler?
I am great. I'm in the UK. I did my mock exams
And
and I definitely failed math. Like it was probably a 2. Yeah.
yeah, but you're at a severe disadvantage.
Yeah, I don't know. Kind of.
Well, based on the fact that I'm teaching you a whole bunch of content in January, February, and March of your second year,
Yeah.
that's tough. That's
Yeah.
tough. And what are you trying to get for your final score?
I think for math I need a 4 to get into the course I want.
Yeah, we can do that.
Okay.
Um, 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 well, what's going on? Is class going to be any help?
I think so. We're still learning new content, which is kind of concerning because we have 5 teaching weeks left. But yeah, it should help. Yeah, probably.
Okay, so well, it doesn't seem like it's helped in the past.
No, not really. No.
Okay, but maybe the review will help. Do you know what the new content is?
I think we're just finishing calculus.
Oh, okay.
Yeah.
Okay. Well, I think I can get you there for mainly because you're smart, and it appears from my end that you're a hard worker. Is both? I know the first one's true. Is the second one true?
Yeah, I would say so.
Okay, I would be. How'd you do on your IA?
My math I think I got a 6. Yeah. So that's working in my favor, definitely. But
That's bussin'.
yeah.
Am I using that right?
I think so.
I thought it was like about food or something.
It used to be, but now it means
It's universal.
universal, right? But yeah, so math is kind of my biggest struggle, and bio. But
My daughter is a senior IB as well, but she's not diploma, thank God. And she came down in a like a prom dress or whatever. And so I threw down, "Oh my God, Caroline, your drip is iconic." And
oh
she
wow,
just she
she must have loved that.
she stared at me and she said, "Thank God it's only 4 months till I move out."
Yeah, yeah. Parents can do that.
Yeah, well, I was, just trying to be annoying. That's my job. Okay, so I forget where we were and what we were doing.
We did stationary points last time, I think, and kind of a few like calculus things. But since the exam, I realized there's things from last year that I need to work on, and since we're probably going to do calculus in class, I feel like I should look at those.
Okay.
And the thing that surprised me was I did not know how to do like bearings. I knew, so it said there's a bearing of so much degrees, and then there's, you know what that is. And then I had to find with only one angle and a bearing from A to B what the area was and what the lengths of the sides were. And I just could not for the life of me figure out the area. That was kind of it. But bearings, I remember finding it pretty easy, but it just completely escaped me. So
Okay. All right. And do you happen to have any questions like that?
no, so
Okay. All right. That's okay. Let me take a look.
okay.
It might be tough for me to find one to where you find the area.
Okay, but honestly, I kind of just need to revise everything. So whatever you think is a hard topic, I can try.
Okay. Well, we'll go to Trig. Okay.
Okay, yeah, that helps too. But yeah, almost everyone failed the mock, I think.
But you haven't. They think they failed the mock, right?
No, we know we failed the mock. Yeah, I filled in less than half of those pages. Like, they don't have to tell us that.
It's not funny.
Mhm.
It's kind of funny. I mean, you
Just
have to laugh or cry, right?
yeah, right, in between.
Yeah, this has bearing in it. Let's see if you want to do this. All right, let me share the screen. This is from the IB question bank, so these are legit past IB exam problems. In fact, this is from last year, probably May, maybe November.
Did people do the exams last year?
I don't know, but the exams were written. How's that? And then
Oh,
they dump them, regardless, they dump them into the question bank.
okay, that makes sense.
So my former school is still letting me have access to the question bank. So that's kind of nice.
Yeah, that is.
But there's plenty out, there's plenty of resources out there anyway.
Mhm.
Revision Village, is that one of them?
No, we use in thinking.
Oh, okay. All right. So you want to read and see if you want to do this?
Yeah. What's the question? Just
Oh, I don't know. I guess that would be nice, wouldn't it? It's, it's freestyle. It's like rapping
yeah.
because making up some dirty beats.
Wow. Yeah. Right.
What's I kind of wish that I actually was trying to like connect with the younger generation, because that's even more cringeworthy than me joking about it.
Right. Right. I know some teachers like that.
Oh, and then you poor people, because you're so nice and polite, you just have to sort of.
Yeah. Yeah. Pretty much.
But then outside class, you have something to talk about. Okay, so find the distance from A to B. Can you still see?
Yes, I can still see.
Okay. All right, the top part. Okay, so want to do it?
Yeah.
Okay.
Actually, yeah, sure. Mainly the angle stuff. The distance stuff just seems pretty easy, but the angle stuff is a little weird. Yeah.
Okay, so find the distance from point A to point B.
Don't you just do 4.2 kilometers per hour time, like, and find out what that is for 45 minutes?
Yep,
I feel like that's
and it becomes 3.15.
yes.
Okay, good. Kilometers, whatever. Show that angle ABC is 101. So that's right here. This
Oh yeah.
angle here, right? So couple of ways to go here. Let's see. So let's see. So
Is it the parallel line stuff?
yeah,
So
sort
that's
of,
100.
yes.
So the other B one is 145. Is that wrong?
Yeah,
Yeah.
yep,
And then
145.
you know the 114 on the other one, and then you just take that away from 360.
The 114 here.
Yeah. Yes, and then
Where do
that's
they tell
100.
us 114?
Adam leaves point B at a bearing of 114.
Thank you. Sorry. So then that gives you 101.
1. Yeah.
Yeah. And you would write the arithmetic out. Okay.
Right. Right.
Find the distance from B to C from camp. So that's here actually. So that's going to be the law of cosines, right?
Yeah. Um,
So this is law of oh my God. So this is law of cosines, this guy, right? And then we would get 6.05. Law of cosines.
why is it 6.05?
AC squared. So this is A, right?
Yeah.
So let's see, this is BII. Okay, so BII. So AC squared. And we already found out that this is 3.15, is that right?
Yes. I think. Or is that
So,
no?
and
That's
this is,
or is that the same? It's the same.
yeah, it's the same. It's from it's this guy. And they tell us that this is 4.6
Mm-hmm.
right here, right? So law of cosine says AC squared is
Oh, a
equal.
squared plus c squared equal squared plus b squared equals c squared.
No, that's it. That's for a right triangle.
Oh.
So let me put the formula sheet up for you. Doot, doot. Every time I see you, your hair is different. I've usually had it up for a while. Then I think
Yeah.
you just got out of the shower another time.
Yeah.
And
And
now this is your hair down.
yeah.
I
No,
look at screens all day, so I see those things. It's not a creepy thing, by the way. Sorry.
Sorry.
Where'd it go? Okay, here we go. I went too far in the formula sheet. So here's your triangle rules, these guys.
Okay.
And they're the first cosine rule is what I'm using because I'm looking for the length of a side. C squared equals A squared plus B squared minus 2AB. So minus 2 times 3.15 times 4.6 times the cosine of the included angle, 101. And then you take the square root of that and you get AC equal to 6.05.
Okay.
Does that make sense?
Yes, it does.
Okay, so here comes the money shot. Find the bearing that Jacob must take to point to C.
Is that the first one in the formula book?
Sort of.
But you have to.
Well, I'm not sure what you mean by that. This?
Yeah.
Well, first of all, let's identify what that is, okay? So that would be, I'll just draw it. I don't have to get fancy. So the bearing he would have to take from C. What? I don't understand. Hold on. And he reaches point C. So it's this one. Wait. I'm not sure what they're asking, Lotte. Hold on.
Yeah, because that would be 101. Yeah, maybe they mean from A to C.
They do. Why did they? Oh, Adam. So Jacob's a new guy.
Okay. I see. And Jacob is on A.
Where does it say that?
I don't know.
Oh, Adam's friend Jacob. It's up here. I covered it.
Okay.
Sorry.
No worries.
I covered it.
Okay. So would you not do 6.05 over sine 101 equals whatever the length is of the angle he needs?
So we're looking, yeah, to find this angle. Yeah.
Yeah.
And then add them, right? So you got it right away. We're looking for this angle. So yeah, it's 35 degrees plus, let's see what they got. Law of sines. Which turns out to be 48.267, which is equal to 83.3.
Yeah. Makes sense. See, all of this makes sense, but for some reason that one
Yeah.
question in the exam was just weird.
Well, I imagine that you had to use that?
Yeah, I probably didn't. Although no, because I only knew one side. It
So
was very,
you must have been somehow able to find the other side, or it was a bad question.
when I get it back, we can go through some of the questions I got wrong. Maybe.
Okay. Okay.
So all of
All
them.
right. All right. So what would you like to do?
Could we do trig?
Sure.
Trig. Is this not kind of trig?
This is trig.
Yeah. Oh, and then there was some weird stuff with, the rules where it's like cosine 2 equals sine plus cosine minus 1 and those kinds of things. I don't know the exact formula, but it looks like that. That was difficult as well. But you have to
Okay.
substitute it.
Okay. Let me try and so like solving trig equations, maybe
Yeah.
using those.
Yeah.
That looks like it. Okay. So now I can update. Let's see how we do. Yeah, here we go. This is good. Okay.
Yeah, exactly. It was a lot of show that.
Yeah. And then really all you have are these guys.
Yeah, exactly.
Yep. Okay. So it's kind of like a puzzle,
Mm-hmm.
right? And I'll talk about some things you can do to help with the puzzle. So you just decide you really just want to work on one side,
Okay.
either the left-hand side or the right-hand side. That's the way to go. Okay.
Okay. I did the
So
opposite in the exam.
you did
That
what?
did the opposite in my exam. I did both.
It's okay, but if you just work on one side, it starts to become a bit clearer.
Okay.
Let's see. And it's kind of like, okay, what have I got? Right? What do I have? I've got formulas for sine 2x, cosine 2x. I've got a 2 sine x, cosine x minus sine x over here.
Mm-hmm.
This whole cosine x minus sine x makes it a little weird.
Mm-hmm.
Yeah, it's a little weirder. So I'm going to go with the right hand side, right? So I'm going to say sine 2x is my friend.
Mm-hmm.
It's nice and concise, and I don't have three choices. So I would start down that road. Okay. So then we would have 2 sine x cosine x plus cosine 2x minus 1. You okay with that?
Yeah.
And then I can also do, I'm looking to like, how do you choose this one? So
Wait, why did what
Oh,
happened
because
to the bracket? But I understand that part, but the bracket on the right,
oh,
what
I'm just
happened?
trying to get to the, I'm just trying to get to this.
Oh, you're starting by changing the left. Okay, I
Yeah,
get
I'm
it.
changing the left and trying to get to the right.
Yeah, that makes sense. Okay.
Okay. Um, I'm sorry. In my mind, I'm trying to decide which is better, which way to go.
Okay.
So I see there's some factoring here, right? And I'm factoring out a sine x.
Yeah. So that's
Yeah.
square.
And there's no 1, right?
Mm-hmm.
So if I look at cosine 2 theta, looky here. I got a sine squared, and if I replace cosine 2x with this, I have a
Yeah.
1 minus 1, the 1's going to go away.
Okay. Yeah, that makes sense.
So you could do that in one fell swoop if you wanted to. So then let's see, plus 1 minus 2 sine squared x minus 1, right?
Yeah.
Okay, so now we have writing down each miserable step,
Mhm.
cosine x, right? And
Yeah.
here we go, kids, minus 2 sine squared x, right?
Mhm.
And looky, we have 2 sine x in common.
Yeah.
Factor that bad boy out, and we got cosine x minus sine x.
Wait, the step before that, how did that disappear? Oh, you
How
just
did
factored it.
this?
Yeah.
Yeah, I
Okay.
factored out 2 sine x.
That makes sense.
Yeah,
Okay.
all good?
Yes.
So it's sort of a matter of, I don't know, I feel like students just like, they don't know what to do. But
Mhm.
luckily in SL, we don't have a lot of choices,
Yeah.
right?
Yeah.
It's
Yeah.
gonna be, it's gonna be these guys somehow.
Mhm. Okay.
So you can sort of just like the sine 2x, that's an immediate substitution,
Mhm.
right? And then from there, you're like, okay, I need to get to such and such. And I look over here and there really isn't a whole lot for me, is there?
Yeah.
To use. And you can, but it's more complicated.
Mhm.
You have to fudge some stuff. Okay.
Okay.
So then this is what I like about IB is they say, hence or otherwise, solve this, right?
Mhm.
Right. So they're giving us a roadmap here, right?
Right.
2x plus cosine 2x minus 1. That's
Is this?
this, right?
Yeah.
But then they throw in minus sine x. Okay, fine. So I can substitute for this guy. So I have 2 sine x, cosine x minus sine x, minus sine x equals 0, right?
Yeah.
Okay, so what do we want to do here? So then we would do,
Do you multiply the bracket?
mm, I'm trying to decide if I want to factor it right now or not,
Mhm.
because somehow this can come out. And we did substitute, right? Correct.
Yes, I
Sine
did.
2x plus cosine 2x minus 1.
Yeah.
Oh, plus cosine x.
Yeah.
Sorry, plus cosine x minus sine x. That's what I missed. Right. So it's just this one.
Yeah.
Well, that's a horse of a different color, isn't it?
Yeah.
So no, we definitely don't want to distribute
Okay.
with this because we can think of this now as two terms if I do this.
Yeah.
So then I can factor cosine x minus sine x out of each term.
What?
And I'm left with 2 sine x plus 1 equal to 0. Is that all right?
No, I don't get it.
So
But
do you, I'm sorry, go ahead.
I don't see why one of the cosine x things disappeared.
So there's a 1 in front of here, right?
Yeah.
And so do you see that I have two terms, term 1 and term 2,
Yeah.
and that each term contains cosine x minus sine x?
Yeah.
So then I just factored that out in front, right? I factored this guy out.
Oh, as in both of those are equal to 0? Like
Well,
both
let's just think about pulling this out, right? And so if I pull this out from this term, I'm left with 2 sine x. Because cosine minus sine x times 2 sine x gives me this full term, doesn't it?
Right. Yeah.
Okay. Plus, and out of this term, I took a cosine x minus sine x, and there's a 1 left.
I don't understand what you mean by took out.
Here, let me do it this way. So let I don't know, let k equal cosine x minus sine x.
Okay.
Okay, so then I would have 2 sine x times k plus 1 times k, right?
Yeah.
Each term has k in it.
Yeah.
So I can factor out the k from each of those terms.
Oh, okay. Yeah.
Right?
Yeah, that makes sense.
We just get confused because of the cosine, and there's a minus, and oh my God, I'm used to variables.
Okay, that makes
That's
sense.
what happens. Okay. I'm just going to put that off as an example there, like in a box. Okay, so now, yeah, we can set them both equal to 0, right? The zero product principle.
Yeah.
So cosine x minus sine x equals 0, or 2 sine x plus 1 equals 0. And let's look at our domain. It's only between 0 and 2 pi, praise be. That's just our unit circle.
Okay.
Okay, and this is I'm sure it's a paper one, meaning no calculator. Yeah, it's paper one. So we got it. How are you with your unit circle?
Really bad. That's the part that I missed when I was not being taught online. It was the whole unit circle.
I tell you what, let's do on that. I'm going to send you a link or two teaching you the unit circle.
Okay.
And if that doesn't do it, then we'll spend a session on the unit circle.
Okay.
I just don't want to waste time and money if we don't have to.
Yeah.
Right? There's some great lessons on the unit circle out there.
Okay.
Okay. All right. So then cosine x equals sine x. So it's asking where on the unit circle they're equal. And instead of trying to teach you teaching you the unit circle, I'm just going to throw one up here that's already filled out.
Okay.
All right, so where does sine and cosine equal to each other? First of all, do you know here that cosine, these ordered pairs are in the form cosine x sine x all around here,
Okay.
okay, instead of xy. The first one says, like here, it means that the cosine of pi over 4 is equal to the square root of 2 over 2,
Okay.
or 45 degrees, but we deal mostly in radians when we deal with the unit circle.
Okay.
Okay, so where is cosine equal to sine? That's the pi over 4 family. Notice all the pi over 4s
Hmm.
are both some form of root 2 over 2.
Yeah.
As their ordered pair, it's just a matter of they're positive or negative. Can you see
Yeah.
this tiny little negative marks? Okay.
Yeah.
Okay. So the only place where they're exactly the same is at pi over 4, where they're both positive, and 5 pi over 4, where they're both negative.
Okay.
So x would equal pi over 4, 5 pi over 4, right?
Yeah.
And then here we do 2 sine x equals -1.
Hmm.
Sine x equals -1/2. Yeah.
Yeah.
Okay. So then we have to know on the unit circle where sine is equal to -1/2. So cosine sine, the nice thing about the unit circle is the ordered pairs reside in what I call families.
Hmm.
So I'm looking for an ordered pair where the sign is either positive or -1/2. I always go to the first quadrant, and it's the only place where that's true is in the pi over 6 family.
Hmm.
If you look all around, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, right?
Yeah.
Sine is either plus or -1/2 all over pi over 6. We need it to be -1/2. So that's going to be the 7 pi over 6 and the 11 pi over 6.
Yeah.
Okay. One thing I will tell you about the unit circle is these are actually x and y coordinates, right?
Yeah. They showed us that, I think. My
Okay.
teacher tried to explain it to me, and he did say that.
Okay. And this is a coordinate system, right? This is an actual coordinate system here. Whoops.
Yeah.
So that means that all the, the ordered pairs here, positive, positive, negative, positive.
Is it the cost thing? Like,
Yeah,
yeah.
but it's just the same as the XY coordinates, right? That's the point I'm trying to make. It's
Okay.
just we threw this stupid circle on there, right?
Yeah.
The other thing, I think the one that I remember is A, S, T, C. All
Yeah.
students take calculus. All
Okay.
the trig functions are positive. Only sine is positive. Only tangent is positive. Only cosine is positive. But I mean, that's a whole, we're opening up a big giant can of worms if you are really bad at it. Where I
Yeah.
think,
I know that, but other than that, I've never been able to use it.
okay, all right. I don't want to waste.
Yeah.
I think it's better if you try a video, and then if you're still not good at it, then I'll show you some things.
Okay.
Okay.
Yeah.
Okay. Where am I? I'm here. Here's more show that. It's exciting. So you have this excellent gift of being able to sound and appear so very calm, like, you know what, I've got this, it's
Hmm.
fine, which is an invaluable gift for your future. And I'm just wondering if inside you're in a total panic.
No.
No, really.
Yeah, honestly, I don't really stress out that often.
What stresses you out?
Um, if I have a good reason to be stressed, but the thing is, I have an offer from a uni I need 24 points for that I really like. So I'm honestly, if I don't get into the conditional one, I'm chilling. So I'm not that stressed. But I do want to do well. So
Yeah,
that's
of course you do. So you're going to get in.
yeah, I'm basically in if I graduate.
I think it's a safe bet you'll graduate. I don't know. Call me crazy. Okay,
Exactly.
so show that this can be written like this, right? So I have 2 cosine squared x plus 5 sine x equals 4, right?
Yeah.
So what the heck is happening here? What's changing? This is changing. And the
Yes.
constant, we can't figure out a constant here,
And
right?
there's a 5 in front of the sine x.
Yeah, and it changes to minus whatever. But we need to get rid of the cosine squared x, right?
Yes.
Okay, so you see cosine squared and you need to get sine squared, you're going to the Pythagorean identity. This is no different than a squared plus b squared equals c squared. It has to do with the unit circle.
Okay.
Okay, so we can all, if this is true, it's also true that cosine squared x, or theta in this case, whatever, doesn't matter, equals 1 minus sine squared theta, right?
Yes.
And I need a sine squared, don't I?
Yes.
So then I'm going to just replace it, and life is going to be wonderful.
Okay.
Right?
Mm-hmm.
Okay, so then we get 2 minus 2 sine squared x plus 5 sine x equals 4, right?
Mm-hmm.
And like it seems okay, but all the signs are different. Oh, I just have to move everything over to the right side. So I'm going to have 0 on the left, and in order of decreasing powers, I'm going to add 2 sine squared to both sides.
Wait, why did? Oh, I see. Never mind. That makes sense. Yeah.
You okay?
Yeah.
So that's 2 sine squared x minus 5 sine x. So your demeanor means that you're going to like be prime minister or president of a country or something. How about that? Could you think you could do that?
I can try. I can try.
So what is your residency? Please say the
My
United States.
right now it's in Florida. Yeah.
It's what?
My residency is in Florida. My citizenship is in Belgium, and my current living area is the UK.
Were you born a United States citizen?
No.
You can't be president.
No, I also don't want to be. I do not want to be president.
I wouldn't either. Why would you want to do that?
Right? It's crazy.
Everything's wrong. Okay. Hence, solve this stupid equation, right? So obviously that means do this, right?
Yeah.
Whenever they say hence, and that is the good thing about IB is when they do say show, if you can't show, that doesn't mean you can't do part B.
Okay. Yeah.
Right? So don't give up on the problem if you can't do part A ever. Always look.
Okay.
And there might be easy points for you. Okay, so now we're just going to say all we're doing is 2 sine squared 2x. Nope, it's not 2x. Why did I do that? It's x. Oh, that's the squared. That's
Yeah.
how dumb I am. 2 sine squared x minus 5 sine x plus 2 equals 0, right? Does that sort of look like an algebraic thing?
Maybe. Oh, quadratic.
Booyah,
Oh
right?
yeah.
So to
Right.
make You did not say booyah. Don't start talking like me. You're going to lose all your friends. So to make this a little easy on ourselves, or maybe you're able to handle it using sine, but let's just temporarily let n equal sine x.
Yeah.
So then we have 2n squared minus 5n plus 2 equals 0, right?
Mm-hmm.
Can you factor okay?
No. No, if there's a number before the first part of it.
Okay, I'm going to show you this way, and if you don't like it, I'll show you another way.
Okay.
Do you agree? 2n.
Yes.
And what we're actually doing is reverse foiling.
Yeah.
Okay. So this 2 comes from the product of the last two guys here, right?
Mm-hmm.
Like this times this has to equal positive 2.
Right.
So that means I need factors of 2, and the only factors of 2 are 1 and 2.
Oh, and then 2 times 2 is 4 plus 1 is, well, no, other way around, negative.
Yeah, I just need them to be negative.
Okay. Wow, that's
Okay.
so simple.
Right. Now, the cheat way is, it's not, hold on one second. Sorry. I got someone in the house.
Okay.
Ah! Yeah. Okay. And then you guys just go, or do we pay? I don't pay you directly. Is that right? Like through the website or whatever. Okay. I just want to make sure. All right. Thank you all so much. Bless you. What was she one detention probably? Yeah. Well, her mom is our doctor, so she gets like she knows when she hears the car, she's like right at the garage door, waiting for our daughter to get home. Thank you. You guys did fabulous. Thank you so much. All right. Bye-bye. You too. Thank you. All right, he's back. Okay. So now, can you go right to n equals 1/2? N equals 2?
Yeah.
But you think. So then 2n minus 1.
1 equals 0. Yeah. Okay.
So n equals 1/2.
Right.
N minus 2 equals 0. N equals 2. But the party isn't over, is it?
No.
And 0 to 2 pi. So 0 is less than x less than 2 pi just means we only have to look at the unit, like one cycle of the unit circle.
Okay.
Okay. We'll tackle that at some other time. So we can talk a little bit more about our good friend here. Okay, so where on the unit circle is sine equal to positive 1/2? From our brief little lesson, are you able to tell me where that is?
Pi over 6 and 5 pi over 6.
You got that right, Jackson. So sine, like the y-coordinate, is positive in quadrants 1 and 2, like any y-coordinate.
Right.
Okay. Now, here's a little dealio. The radius of the unit circle is 1.
Yeah.
So that's why 1, 0, 0, 1, -1, 0, 0, -1, right?
Mm-hmm.
So that means the greatest that sine or cosine can be is positive 1, and the least sine or cosine can be is -1.
Okay.
So anytime you have sine or cosine of something equal to anything greater than 1 or less than -1, there is no solution.
Okay.
So that's always wonderful.
Okay.
You okay?
Yeah.
Okay. Woohoo! Okay, I'm not doing this until we get you okay on the unit circle.
Is that the end of that question?
Yeah.
Oh.
Yeah, just A and B.
Okay, cool.
How about that? Okay, there's some calculus in here too, so it's a good way to end.
Okay.
Because you've already done derivatives and tangent and all of that.
Yeah.
I'll make that teeny tiny. Teeny tinier. Is it okay if we go a little over our hour?
Yeah, that's fine.
Okay. I just don't want to leave in the middle of it, and I don't have a student after you, so cool. Okay, so let theta be an obtuse angle such that sine of theta equals 3/5. So when they tell us the angle is obtuse or acute, do you remember what obtuse means?
Above 90 degrees,
And less than?
less than 180?
Good.
No.
So remember in Trig that our angles start at 0, like here, and
Okay.
rotate this way. So what they're telling us is that we're in the second quadrant. That's why they tell us this.
Okay.
Okay.
Yeah.
Okay. And then let f of x equal e to the x sine x minus 3 pi over 4. Okay, whatever. That comes later, right?
Yeah.
So A, what happened to C? Did they just miss? I didn't miss something, did I? Nope. There's no C. Great. Okay. That must be. Whatever, we can do it. So A, I'm going to go back and get our trig stuff here. I'm going to put that over here for us. Okay. So we know that sine of theta equals 3/5, right?
Yeah.
And we know that tangent theta equals sine theta over cosine theta.
Yeah.
And we already know that sine theta is 3/5.
Yeah.
Right? over cosine theta. And we don't know cosine theta. So what they're really asking us to do is find cosine theta, right?
Yeah.
And whenever you have sine or cosine, you can always find the other one using this guy.
Okay.
Okay, so I'll just write it out. Cosine theta plus sine squared theta equals 1.
Mm-hmm.
So cosine squared theta plus 3/5 squared, because that is the sine of theta given to us right here,
Mm-hmm.
equals 1. Cosine squared theta plus 9/25 equals 1. Can you do fractions in your head or no?
Yeah.
What do we get
Um,
by moving it over?
oh, 1 minus 9/25
Which
is
is?
16.
Yay. Okay, so then we take the square root of both sides, right?
Mm-hmm.
And we remember to put plus or minus in front. You okay with that?
Yeah.
Okay, so now this is where the whole obtuse thing comes into play. Because in quadrant 1, cosine is positive.
Yeah.
But in quadrant 2, cosine is negative, right?
Yeah. So it's negative.
Yeah, so that means since in quadrant 2, cosine is negative. So cosine theta equals -4/5. So tan theta equals 3/5 over -4/5 equals -3/4.
Okay.
You okay?
Yeah.
Okay. All right. So B,
Wait, -3/4 is because
3/5 divided by -4/5.
yes, that makes sense. Yeah.
You okay?
Yeah.
Okay. All right. Line L passes through the origin and has a gradient of tangent theta.
Mm-hmm.
Find the equation of L. Why don't they tell me what that is? Oh, they do tell me this is F. Oh, I didn't see this F. Okay, so this is the graph of this horrific function here.
Okay.
Okay, so
Yeah.
now line L passes through the origin and has a gradient of tangent theta. Find the equation of L. This is fantastic news, because if line L passes through the origin, then it passes through 0, 0, right?
The origin is what?
The origin is the intersection of the x and y axis.
Okay.
Okay.
Yeah.
Okay, and if it's the slope is equal to the tangent, then m equals -3/4, right?
Right.
Okay. The nice thing about IB is even if you don't get A correct, let's just say you use +3/4.
Mm-hmm.
If you use +3/4 correctly for question B, then you get full credit for B.
Okay.
Okay, so given a point and the slope, do you know how we could write the equation of line L?
Is the point the y-intercept?
It is, because it's x equals 0, isn't it?
So
Plus it's
then,
the origin, so it's on the y-axis, right?
right. Okay. So then it's y equals -3/4 x.
Excellent. Okay.
Yeah.
Okay. So I'm going to take this guy and bring him down. And whatever happened to C, it's a mystery to all of us. We don't care.
If you hear people shouting, it's people next door.
Can't. I actually have my dirty beats going on in the background at a very low level.
Wow.
I know. Wow that I said dirty beats, or
Just wow.
just an overall wow.
Yeah.
Oh my God. Okay. All right. So we got all this going, right?
Mhm.
Okay. So line M is parallel to line L. So we just found line L, right?
Right.
So if it's parallel and goes to the origin, are you cool that it's not like that at all?
Yeah.
It's like this.
Yeah.
Okay. Not sure if it'll help us, but just want to make sure we're good on that. Okay. Line M is tangent to the graph of F at point P. Find the coordinates of point P. Okay, that means that the slope of M is what?
Opposite reciprocal.
They're parallel.
Oh, you mean, wait. Oh yeah, M is that one. Sorry. Of M is the same as L.
Very good, right?
Yeah.
Okay. So that means, let's just say that P has the coordinates AB. Okay. Do you recall what the derivative it tells us?
The gradient of the tangent. Is that right?
Yes.
Okay.
Yes. And we certainly have a tangent line, don't we?
Yes, we do.
So that means that F prime of A is equal to -3/4.
Yes.
So we're going to find F prime of X. So F of X is e to the X sine X minus 3x over 4. Is that right?
Yes.
Which is 3/4 X.
Oh, I see. Okay, I get it.
Right?
Yeah.
Just from over here. So you wanna do some derivative work?
Sure, why not? Okay.
So we got two functions. We got this guy and this guy, which we do separately because it's subtraction.
Okay. Now that first part.
No clue?
Do I have to do the one of the rules?
Yes.
Chain
And
rule?
what is e to the x doing to sine of x? It's multiply.
Oh yes, multiply. Yeah.
So we're going to use the product rule.
Okay.
And the product rule, if you forget, is the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second.
Okay.
Okay, so the derivative of e to the x is e to the x. Do you remember that? It's in your formula sheet.
Oh, yes.
Okay. Do you remember what the derivative of sine is?
No.
Derivative of sine is cosine. That's in your formula sheet,
Okay.
as is the product rule.
Okay.
Plus the first e to the x. Oh no, the derivative of the first, which is e to the x, times the second.
Yeah.
And do you know what the derivative of negative 3/4 x is?
That's to the power of 1, right? Yeah, it is. So negative 3/4 x to the power of -1?
To the 0, because
Right,
1
yeah.
minus 1 is 0. And
Yeah.
what's anything to the 0 power?
1?
1. So anytime you just have something times x, its derivative is the coefficient.
Okay.
Okay. Now we know that f prime of a is negative 3/4, right?
Yeah.
So if I replace the derivative with negative 3/4 and I solve for x, I get the x coordinate of p. Because remember, we name the coordinates p, a, b.
Right. So we figured out the slope of m.
Mm-hmm.
We're using that.
To find the x coordinate.
Okay. Yeah. Okay.
Okay. So e to the x cosine x plus e to the x sine x minus 3/4. Yes.
Mm-hmm.
So do you see how we get 0 equals e to the x cosine x plus e to the x sine x?
Yeah.
And so we're solving for x. So what can we factor out?
E to the x.
Good. 0 equals e to the x times cosine x plus sine x.
Yeah.
So we have e to the x equals 0, or cosine x plus sine x equals 0.
Okay.
Okay. It is impossible for any exponential function to equal 0. In other words, there's no real number raised to a power that will equal 0.
Okay.
And e is a real number, 2.7, nobody cares. So no solution.
Okay.
So we're back to your favorite, the unit circle. Okay.
Yeah.
And I'll just save us some trouble here. Let's look at our domain. Oh, it's from 0 to 3. Okay. So actually, no, let me go ahead and get the unit circle. It's good practice for you. And honestly, what do you have to do right now?
Nothing. Except
Wait,
that,
are you back? So you're in England. Is school in England?
yes, boarding school.
And are you at school?
Yes.
Has school started again?
Yes.
When? This week?
Last week we had mocks, and this week is school.
Gotcha. What's today? I can't keep track of days. Wednesday.
Is it Wednesday? It's Wednesday. Okay.
Don't do that to me, because I okay.
It's Tuesday.
All right. So our domain is from 0 to 3, because they say that right here, right?
Yes.
Okay. So we have to think radians here as to where on our unit circle, right? So notice 0 to pi is right here.
Yeah.
Right? And pi is 3.14 about. So
Yeah.
0 to 3 is very, very, very close to pi, right? So it's like whatever. That's our domain on the unit circle. Yes. So we have to look where cosine and sine are the same, but negative, and that's here.
Is that what going to 3 means? Just going to 5?
Well, all I'm saying is that we only have to consider values of x from here to here. We don't have to worry about the rest of the unit circle.
Because pi is around 3.
Yeah.
Okay.
Yeah. Sorry about that.
No worries.
That I went too fast. Okay, so where cosine and sine have opposite signs, SIGN, is at 3 pi over 4, where one is positive, one is negative √2 over 2, and the other one is positive.
Okay.
So that means that x is equal to 3 pi over 4.
Yeah.
Okay. So that means for point P, we have 3 pi over 4 and y, right? Or
Yeah.
f of x.
Yeah.
But thankfully, these wonderful, wonderful people have told us that f of x equals e to the x sine of x minus 3x over 4. Oh my God. So f of x, I'm going to forget this, equals e to the x sine x minus 3x over 4. Is that right?
I think so.
Okay, so we just have to plug in 3 pi over 4. Whatever, no big deal.
Yeah.
Equals e to the 3 pi over 4, right?
Mm-hmm.
Times the sine of 3 pi over 4 minus 3 times 3 pi over 4. Actually, let's do it this way. That's dumb. Instead of 3x over 4, let's think of that as 3/4 x. How about that?
Okay.
That's a lot easier. And we just need to clean this up. We don't have a calculator. There's absolutely nothing that we can do with e to the 3 pi over 4, so we're done with that. Sine of 3 pi over 4 is positive √2 over 2 from our unit circle. So I write a 3 minus 9 pi over 16. And there's really nothing else we can do with that.
Okay.
That is awful. Let me check the mark scheme, make sure I'm not being dumb. Yeah, wow, that must have been part C, but they did ask us, right?
Yeah.
So, okay. So 3 pi over 4, this terrible, terrible thing. I did 3 again, minus 9 pi over 16
Okay.
is point P.
Great.
Was that awesome or was that awesome?
That's awesome. Yeah. Excited to do that.
Such an American word, awesome, right?
Yeah.
I don't think it happens anywhere else. Okay, so we are on again tomorrow, is that right?
Yes.
And you have school tomorrow.
Mm-hmm. Yeah.
But the weekend's coming up, right?
Yeah, it's coming.
Okay. All right, Lotte, it's good to see you again. And I think Mom said twice a week for the foreseeable future.
Yeah.
Should I make the arrangements with you? Because I couldn't do permanent for the next 2 weeks, like the same days. So
Yeah. Okay.
should I run the days by you or Mom?
You can run it by me because I'm here. So.
Okay, I'll put it in my email where I'll include the notes and the link and all of that and give you the options. So, all right.
Yeah, perfect.
Have a good night.
Thank you too. Bye.
Bye.